So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is a very unmasked coder this side. So welcome to another lecture of binary tree. So the problem we are going to discuss is maximum width of a binary tree. Obviously this is a root, and what is asked from you is for the given binary tree, what is the maximum width? Now what is the width? So the width is defined as the maximum distance between two nodes at same level if the tree was a complete binary tree. If the tree was a complete binary tree, right? Suppose for this tree, let me zoom it in. For this tree, 1, 2, 3, 4, 5, 4, 6, 8, 7. What is happening is if you see in the level 1, let me mark it here, in the level 1, right, you can see only one node. So the maximum width is the starting node is this one, start is this one, as well as end is this one. So only one is there, right? So only one width is there from the level 1. For level 2, what is happening? You can see for up till level 2, if you see this part of the tree, this is actually a complete binary tree, right? So I don't want to assume anything. This is a complete binary tree. So how many nodes are there? Start node is 2 and end node is 3. How many? What is the width? What is the width? That is what is the distance between them. So it is 1, 2. So this width is 2. In the level 3 now, in the level 3 you can see 4 is there, start is 4, end is 6, right? Now most of you will say that the width is 2 here also. No, the width is not 2. Now the question says in a complete binary tree. Complete binary tree is an important aspect here. That is, if I try to draw the structure of this binary tree as a form of complete binary tree, what will it look like? It will be 1 as it is, 2 as it is, 3 as it is, 4 as it is, 8 as it is, 6 as it is, 7 as it is. But if I try to draw the complete binary tree, I will have to add some nodes, right? If it was a complete binary tree, there would have been a node here, there would have been a node here, then there would have been a node here, there would be a node here, node here, node here, node here. I will not draw a node here. This node is not acceptable. Why? Because complete binary tree says that up till here, this is the end node, right? This is the end node. I will end my level traversal here, right? Okay. So what is happening is start is 4, end is 6, right? Start is 4, end is 6. How many nodes are there? So if I count 1, 2, 3, 4. So answer here will be 4. Let me mark it here. So answer from the level 3 is 4. Moving on to level 4. Start node is 8 and end node is 7. What is the distance between these two nodes? So if you see 1, 2, 3, 4, 5, 6, 7, right? So 7 nodes. So 7 nodes. Out of 1, 2, 4, 7. What is the maximum? Obviously 7. So I will say my answer is gonna be my 7. You have to return this answer. You have to return this answer. That is, for the given tree, you have to draw its complete binary tree and then go up to the last level. That is, I'm assuming you are finding it correct, right? Now, how to solve it? How to solve it? So initially I tried using the vertical level. Initially, my attempt, this is my attempt, I tried using vertical level, that I will say it is 0, it is -1 level, it is -2, it is -3, and it is 1, it is 2, it is again 1, right? And for a level I will say what is the maximum, what is the minimum. So it is 0 comma 0 here, -1 comma 1 here, -2 comma 2 here, and -3 comma 1 here. So it was giving me one node, it was giving me 2, it was giving me 4, and it was giving me 4. But you can see the answer is 7. That is my, this approach was wrong. Why was my approach wrong? Why was my approach wrong? Because you can see that for this 4, you can see that this also was at level 1. This is also at level 1. If I assign a value here, you can see 1 minus 0 minus 1, that is 0, 0 plus 1, that is also 1. So this node is also at 1, and I'm not counting this node. I'm not counting this node. So what can I do? What can I do? What can I do? It is pretty evident that level order traversal is keeping me intact here, that I will have to use level order traversal somehow. I will have to use level order traversal somehow. Why? because only level traversal can give me that how many nodes are there on a level, right? So first thing we confirmed is level traversal. Not confirmed, this is my like gut feeling. Why? Because I have to move along the level, right? I have to move along the level. As I did, that level 1 was giving my answer as 1, level 2 was giving my answer as 2, 4, 7. So there is something that I have to go level wise. I have to go level wise because I have to go level wise, right? Okay, so this thing is confirmed that we are going to try using level traversal, and if this doesn't work, then we will try something else. Right? But how will level order work? How will level order work? So let me draw the tree here. So tree is 1, connected to 2, connected to 3, connected to 4, connected to 6, connected to 8, connected to 7. Right? This is my tree here. I hope I have made the tree right. Yeah, this is a tree. Now, how will I do the level or traversal? Level or traversal, what it will do? It will say that I will give you 1, I will give you 2, I will give you 3. No problem, I wanted that. But 4 given, 4 it will give. But what about this node which was imaginary in a complete binary? And what about this node which was imaginary? It will not be able to give me the imaginary nodes, right? It will not be able to give my imaginary nodes. And for somehow, if I mention this node into my queue as imaginary, then also there is no meaning, right? Because I will not be able to add these two nodes here, right? That would be a problem. So what can I do? I have to apply my mind somehow. So the answer that came to me is using somewhat of heap. How heap? So in heap we understood that heap is represented using an array, represented using an array. What does it mean? That is heap is a complete binary structure first of all. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose this is my heap. How will I represent it? It is represented using 1, 2, 3. Simple level traversal. 5, 6, 4, 5, 6, 7, 8, 9. This is a heap representation. If I mark the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8. And now if I try to form the relation between the parent and its children, you can see that 1, that is index 0 has children as 1 comma 2, index 1 has children as 3 comma 4, index 2 has children as 5 comma 6. You can see that this is index 1 0 1 2 3 4 5 6 7 8, right? 3 has children as 7 and 8, 4 has children as 4 doesn't have a children actually, 5 doesn't have a children, 6 doesn't have a children, 8 doesn't have a children, 9 doesn't have a children. So actually from heap I'm just deriving that a complete binary tree can be represented using an array with the relation that parent index equals to y, then left child index is gonna be, you can see between these relations, right? Left child index is gonna be 2y plus 1. You can see 0 into 2 plus 1 gives me 1, 1 into 2 plus 1 gives me 3, right? 5, 3 will give me 7, right? And right child index is, it is gonna be 2y plus 2. We have derived it in the heaps video as well, so if you have not watched it, please watch it, and please follow that playlist also to master heaps, right? So what did we concur? That a complete binary tree can be represented using an array with these relations, that for an index I, 2i plus 1 and 2i plus 2 are its children, right? Can I do something like that? Suppose I give it an index 0, this is the index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. If I give them index, that is in the level of traversal, let me draw the tree again downwards. 1 connected to 2, connected to 3, connected to 4, 6 here, 8 here, 7 here, right? This was the tree, right? What I'm saying is in the queue, obviously we are storing a queue. In the queue, we push 0, 1, comma 0 first. What is 0 here? 0 is the index. That is, we are pushing node, comma, index in the queue, right? This is my queue. I pop it out. 1, comma 0 has been popped it out. Now, also in the level of traversal, we see that what is the current state size of the queue, that is that many elements are there in the level, right? So current size is n equals to 1. I see that first one is this one, last one is this one. So what can I say? It is 0 minus 0 plus 1. This particular level is giving me 0 minus 0 plus 1 width, right? So initially my answer was 0, but now it is getting updated to 1, right? And it has left kid as 2, so I will push in 2 and I will push in 3. But what are the indexes I will push them with? So index 0 will get converted to 0 into 2 plus 1 and 0 into 2 plus 2, that is 1 and 2. So I will push 2 comma 1 and 3 comma 2, right? The index of this was 0, this index of this is 1, index of this is minus 2, right? So moving on, when I will pop out 2 comma 1, I have 2 comma 1 in my hand and I will see that n equals to 2, and I will pop out 3 comma 2 in the same iteration, that is for n equals to 2 only. I will see the first index is 1 and the last index is 2. So 2 minus 1 plus 1 will give me the width of 2. So this level is giving the width of 2. I will update my answer to 2. Moving on, n equals to 3, not n equals to 3, sorry, I will push the values. So let me push the values. This has been popped out, sorry for the error in dry run. Okay, so I will push in 4 first and then I will push 6. For 4, 1 into 2 plus 1, that is equals to 3, index 3. And for 2, 2 into 2 plus 2, because it is right child, so that is 6. So 6 comma 6 has been pushed, right? I will pop both of them out in n equals to 2 right now, right? 4 comma 3 has been popped out and 6 comma 6 has been popped out. So 4 comma 3 in the first, 6 comma 6 in the second iteration, and I will see that the first length is coming out to be 3, second length is coming out to be 6. So 6 minus 3 plus 1 gives me 4, and you can see if you draw the complete binary tree, 1 2. So 1 2 3 4, 4 is my current level width, right? Okay, so 4 answer will get updated to 4, right? And before popping, you will pop out right the left and right side also. So 8 will be given with 3 into 2 plus 1, that is equals to 7. And 7 will be given with 6 was given with 6, so 6 into 2 plus 1. Why 1? Because it is left child. So 6 into 2 plus 1 gives me 13. So 7 comma 13 has been pushed out, and equals to 2 again. That is, I will have 2 iterations to pop out of the elements, 8 comma 7 and 7 comma 13. And when you pop them out, you will see 13 minus 7 plus 1 gives me 7, and answer will get repeated to 7, and you will return this 7 as your answer, right? So what is actually happening? We are giving the index. For the left child 0, it will be 1, it will be 2, it will be 3, and 2 into 2 plus 1, 2 into 2 plus 2 will give me 6, then 3 into 2, that is 6 plus 1 give me 7, 6 into 2, that is 12 plus 1 give me 13, and 0, 2 minus 1, 6 minus 3, 13 minus 7 will give me the answers, right? So what is actually happening? We are taking the help of indexes. Taking help of indexes, right? Now there is again a problem. I tried using this, but there is a problem. What is actually happening is, so you see 1 connected to 2, connected to 3, connected to 4, connected to 6, connected to 8, connected to 7. What is actually happening is, index was 0 here, it came to 1 2 here, it came to 3 and what do we say 6 here, it came to 3 into 7 and 13 here, right? So you are seeing that index is actually increasing exponentially by multiplying by 2, right? Index is increasing exponentially, index is increasing exponentially. But when we are coding, we have limited value of indexes, limited value stored in an int contains limited range. What is that range? 2 to the power 31 minus 1. So you will say use long int, right? But I tried using long int also, it was giving overflow error. That is, the number was getting bigger than the long int also. So I will have to do something else. I will have to try to optimize it. So optimization stuff is left. Optimization. How will I optimize it? So if I see evidently that this 1 comma 2 can be reduced to 1 minus 1, that is 0, and 2 minus 1, that is 1. This 3 comma 6 can be reduced to 0 and 6 minus 3, that is 3. 7 minus 7 comma 13 can be reduced to 7 minus 7, that is 0, and 13 minus 7, that is 6. What I'm actually doing is I just want the difference. See, I want the difference, first point, right? So what I'm saying is h minus L is actually equals to h minus L, oh sorry, h minus L minus L minus L. High minus low is actually equals to h minus L minus low minus low. It is just plus minus L operation, right? That is I'm doing. So that is the first one is minimum I know. So what I'm doing is I'm actually reducing it with all of them, right? Okay. Now it is time for us to see how will we do it, right? So what is actually happening is 1, 2, 3, 4, 8, 6, 7. Your answer is 0 right now. You have a queue, right? And queue contains node with the indexes. You push in 1 comma 0. You push in 1 comma 0. 0 is the index, 1 is the node, right? Let me circle it, right? You pop it out. And for the current level, n equals to 1. This is the size of the queue, right? Before popping it out, right? Now what do? You push in the left and the right first. You push in the left and the right. So 2 will be pushed in with 1 because it is a left child, and 3 will be pushed with 2, right? Now you will see that for n equals to 1, this is the first, this is the last. So 0 minus 0 plus 1 will give me 1. So I will update my answer to 1, right? Moving on, for the second time, it will see that n equals to 2, that the current level contains 2 nodes, n equals to 2. Okay? So the first node is 2 comma 1 and the last node is 3 comma 2, right? You will see that 1 is the lowest value, so reduce. So 2 comma 1 will be reduced to 2 comma 0 and 3 comma 2 will be reduced to 3 comma 1. Why? Because 1 minus 1 is 0, 2 minus 1 is 1, right? And you will see the first node is 0 plus last node is 1, so 1 minus 0 plus 1 will give me 2, and I will update my answer to 2. And you will push in 4 comma 4 comma 0 into 2 plus 1, that is 4 comma 1, and 3 comma 1 into 2 plus 2, that is 3 comma 3, right? Again n equals to 2 for third level, right? You will pop that out. The first element is 4 comma 1, last element is 3 comma 3. You will again indexes will be rolled out, so it will change to 0, it will change to 2. 2 minus 0 plus 1 is giving me 3. 2 minus 0 plus, oh, it will be 2 here, it will be 2 here, it will be 3 here, so 3 minus 1, it will be 4. I will update my answer to 4 and I will move to 8 and 7, right? I will move to 8 and 7. So n equals to 2 again for 8 and 7. What are the nodes value in the queue? So 8 is pushed with 0 into 2 plus 1, that is 1, and 7 is pushed with 3 into 2 plus 1, that is equals to 7, right? So I will pop it out. First element is 8 comma 1 and last element is 7 comma 7, right? I will see it will be changed to 0, it will be changed to 7 minus 1, that is 6. So 6 minus 0 plus 1 is actually giving me 7 as my answer, and that is my answer. That 7 is my answer because it will get updated to 7 and I will return it, right? So I'm actually using a level traversal with some index shortlisting and index reducing, right? Okay. Now let us move to the code. I hope you're clear with the question. So let us start writing the code, but before starting it, it's my sincere request to you to please subscribe to the channel, right? Firstly, I will say int answer equals to 0. Okay, before that, let me write down something like this. If root equals to null, just return it. No need to do something else. Return 0, right? Now make a long answer, right? Now what will you do? You will say queue of pair of, first is tree node star with a long value. We will be storing the indexes, right? Name it as queue. Now, if obviously my root is not null, that is why this condition is not getting meet up. Then queue dot push. What do you push? You push the root with the value of index. You are storing index 0 in the root. Now, while my queue is not empty, what will you do? You will say int n equals to queue dot size, and you will say int subtract, which I have to subtract from all of them, is equals to queue dot, let us say long int, right? Long int subtract equals to queue dot front dot second, so dot second, right? This is a sub. And now for int I also take the first and the last values also for the updation of the answer. So long int first and second, right? Now for int I going from 0 up till n I plus plus, pop the n elements that are from the current level, right? We will do tree node star node equals to q dot front dot first and int index equals to q dot front dot second, and subtract it here only to make it inbounds of the integer or the long int, right? Now then q dot pop, because the current we are going to explore, so q dot pop. Now if node left is not null, in that case q dot push the node left along with index multiplied by 2 plus 1. And now similarly, if node right is not null, then q dot push node right along with index multiplied by 2 plus 2, right? And now if I equals to 0, that means it is the first, it is the leftmost one, so first equals to index, and if I equals to n minus 1, then last equals to index, right? After the current level has been done, update your answer. So answer equals to max of answer comma last minus first plus 1, and then you can release your answer as return, right? Let us try to compile and run it. Hope it will work fine and will not give any error. Okay, there is one mistake. Okay, it is not second, it is last. That is the rightmost, right? Let us try to compile and run it now. I hope it will work. Okay, it is working fine for the sample test cases, and it should work fine for the backend test cases as well. There has been some error in line number 18. In line number 18, there is, okay, I have to declare it as long int. Let me write it down. Let me work it up now. Hope it will work. It is working for the sample test cases. Let's try it for the submit. And it is getting accepted. So thank you for watching. Hope you liked it, and make sure to subscribe to the channel and like the video. I believe that question was difficult. Question might have gone some little attention, but please watch the video again and you will get all the concepts, right? Meet you in the next video. Till then, stay tuned and keep coding. Thank you. Have a nice day.